So good evening, and thank you for joining us here at the PDST Post-Primary Maths Team webinar on GeoGebra. Before we get started, I would like to outline some protocols for this webinar. Firstly, we ask that there is no recording of audio or video made of this webinar. PDST do not grant permission to record. We will, however, make a recording of the webinar available online after the event. At the bottom of your screen, there are a number of features on your toolbar. The closed captioning option is enabled. You can turn the subtitles off by clicking on the CC button and hide subtitles. The size of the captions can also be adjusted. All links and resources will be emailed to you after the event, so don't worry if you can't access them immediately. Depending on what type of device you're tuning in from, you may have limited screen space. To help with this, you might consider minimizing the speaker view so that you can see the full presentation. The chat button will be displayed at the bottom of your screen or by pressing the More button. Some useful information may be communicated to you through the chat function. When these links are posted, you can access them by clicking on the link. This will open a new tab in your web browser. The meeting will continue and you will be able to hear everything while looking at the web browser, and you will not be logged off the webinar. At certain stages, we may ask you to answer a question using the poll function. The question will flash up on your screen and you can select the appropriate response. These are anonymous responses and we would appreciate your participation. You should see an example on your screen now. Finally, we would like to remind you that this is not our team's remit to answer questions specific to state exams or CBAs. But at any stage during the webinar, please use the Q&A function at the bottom of your screen to ask your questions. You can ask anonymously by ticking a box when you submit the question. We will monitor the questions during the webinar, so please make use of this function. Tonight's webinar is focused on GeoGebra. So what is GeoGebra? GeoGebra is a free, dynamic, easy-to-use maths software package. It's used by teachers and students in classrooms all around the world to promote inquiry-based learning in maths and to support a constructivist approach to learning. GeoGebra provides a platform for students to become independent learners and take ownership of their maths. So you noticed we had shared a poll on your screen. This poll is anonymous and we're using it to know more about your usage of GeoGebra. I'll end the polling and share results. So by responding to this poll, we have a better idea of the experience of everyone attending tonight's webinar. So as we can see, 44% of people here use GeoGebra for a demonstration for students with pre-made GeoGebra files, whilst 31% demonstration for students with GeoGebra file that they created themselves. Students engage with a pre-made file, 33% students engage with a GeoGebra file I created. Students create their own GeoGebra file, and none of the above. Okay, well, I have good news. Regardless of where you responded there, tonight's webinar is for you. Okay. So tonight's webinar will be split up into two parts. The first part is this introduction and welcome, followed by a demonstration by my colleague Arlene Murphy on getting started with GeoGebra. Here, Arlene will demonstrate the use of GeoGebra, creating an account with GeoGebra, and finally creating and downloading GeoGebra files. The second part of tonight's webinar will be with another colleague of mine, Angela Dewan, on effective engagement with GeoGebra. Here, Angela will take a look at using some pre-made files. She will discuss how, with a bit of planning, we can provide students with a rich task that promotes critical engagement. This will then be followed by a Q&A session to finish the webinar. To help you on your journey with GeoGebra and to follow along with tonight's webinar, we have made a Padlet resource available. The link to the Padlet will pop into the chat now. I will also demonstrate the Padlet for you now. So as you can see, the Padlet here consists of different columns containing resources such as videos, PDF files, and GeoGebra files. Both Arlene and Angela will be referring to this Padlet during this webinar. On the left-hand column, you can see links to get in touch with us. If you need support with teaching mathematics, we are always happy to help. As with all of our events, we start with key messages. The key messages we're going to work with tonight are: GeoGebra can be a useful digital tool to promote inquiry-based learning in mathematics, and the effective use of GeoGebra can support a constructivist approach to the teaching and learning of mathematics. A rationale for using GeoGebra. Here in bold on your screen, the Leaving Certificate Math syllabus states, at all levels, learners will engage with the dynamic geometry software package. That's on page 23 of the syllabus. We can also see the power of incorporating GeoGebra into our practice. We will see later tonight that with a bit of planning, we can provide students with a rich task that promotes critical engagement, thus giving our students the space to engage purposefully in meaningful learning activities. In turn, giving our students a chance to work both independently and collaboratively in a very purposeful and productive manner. Here we have adapted Domain 2 learner experiences from Looking at Our Schools 2016, page 15. The second statement here is taken from the Digital Learning Framework for Post-Primary Schools. In Domain 1, Learner Outcomes, the standard we have chosen to highlight is students enjoy their learning, are motivated to learn, and expect to achieve as learners. GeoGebra file can be used on most devices, such as a PC, a laptop, an iPad, or a phone. And we'll see how these files can be manipulated with a mouse or by touch. We can then describe GeoGebra as a digital technology that allows students to foster their active, creative, and critical engagement in attaining challenging learning outcomes. Now, before going into the next section of our webinar, we're going to launch a poll about which platforms or VLEs you are currently using. I'll take a moment now to allow you to submit your answers. So I can see answers coming in here. Thank you very much for responding. And I will end the polling. I'll count 5, 4, 3, 2. Looks like no one else is going to. Okay, end polling. And I'm going to share the results. And we can see the different uses of the platforms: Microsoft Office 365, Google Suite, GeoGebra Classroom, Edmodo. Okay, great. So now we're going to be brought through getting started with GeoGebra with Arlene Murphy.
Yeah, thank you, Michael. Okay, folks, so this session will be divided into 3 different parts. How to get started with GeoGebra, how to create and use an account, and creating a file. In the Padlet, under session 1, oops, there we go, under session 1, there is a document of instructions, this first one here. Now, this document can be used as a guide for this session, or it is available on the Padlet for future use. If you're using a PC or a device that allows you to move easily between apps, do feel free to open up GeoGebra and follow some of these instructions as we go through the section. If you have any questions, please pop them into the Q&A. And I do hope that whatever level of GeoGebra you're at, that you will get some tips and tricks from this session. So we're going to start at the beginning. If you are completely new to GeoGebra, where should you begin? Well, first of all, I would advise you to download GeoGebra to your device. There is an online version, but downloading it as an app just means that it can be used offline. It is also a good idea to ask your students to download it to their devices so that it can be used in class or at home. So if you go to this website, www.geogebra.org, here on the left-hand side, you go to App Downloads. And here you will see a choice of GeoGebra apps. Now, if you don't want to download the app to your device, you can instead click on the Start button here under GeoGebra Classic 6, and that will bring you to the same version, the same online version as I will be using this evening. To download GeoGebra Classic 6, you click on Download, and this is the one I'd advise you to download because it is the most recent up-to-date version, and its files are compatible for use on tablets and phones as well as PCs. To download GeoGebra onto a phone or tablet, you simply go to your App Store, which is your Play Store for Google or the iOS for Apple, and search for these. So GeoGebra Classic on iOS, GeoGebra Geometry and Android. And this is the icon here that you will be looking for. Now, those instructions are in the Padlet. And if you're having any technical difficulties, you can let us know through the chat function. We'll try to help you out straight away. Now that you've downloaded the app, where to next? So first of all, it is a good idea to set up an account. That way you can save any files that you create or any files that you find useful and share them with your students. Note that you do not need an account to interact with any GeoGebra file, and your students don't necessarily need to have an account either. And also, if you create a file yourself or if you share a pre-made file with your students, what they are working on when they're changing things, they cannot change the master file. So we're now going to go to the GeoGebra app from my own PC and we'll create a file. So in the GeoGebra app, if you go to the menu here on the top right-hand corner, the 3 horizontal bars will bring you to the main drop-down menu. If you go to the very bottom of this drop-down menu, there is a button to sign in. So if we click on that, it then gives you an option to sign in if you have an account. And as you can see, you can also sign in through Google, through Office 365, etc. Or you can create a new account, or indeed, if you forgot your password, you'll pop it in there. So I'm just going to very quickly log myself in. There we go. So once you've signed in, you can access any of your saved files by going to the same drop-down menu, the 3 horizontal bars, under File, and press Open. Now, what you can see here is all the files that I have created and saved. And these can be viewed, they can be edited, deleted, or shared with your students, or indeed with colleagues at any time. But the other thing about GeoGebra is here on the top is a search bar. So if you were to search for example for bisector and press enter, well, what comes up is bisector files that have been created by anybody that has created them on a shared platform. So GeoGebra uses a Creative Commons license, and that means that content created on the site or on the app is freely available for educational purposes. So instead of creating files, you can go into any of these and choose to view it and to share it with your students. I will demonstrate how to share files after we create a small one ourselves. So once again, all that information is in the document from the Padlet. And if you have any questions, do not hesitate to ask. So now that we've set up now that we're set up on GeoGebra, let's create our file. So again, if you're using a PC, you might want to work through the task as we go. It would be more difficult to do on a phone or tablet, but you still will have the instructions to try it out in your own time. This evening, we're going to create an angle. We'll bisect that angle and do a little exploration. This forms the prior knowledge needed for the next section of the webinar. So you can create this file and share it with your students, or you could ask your students to create the file themselves if they're used to using GeoGebra. I will share with you a pre-made file at the end of the section. So however the file is shared or made, it's really important that students have clear instructions on what to do with that file. A good starting point is asking them to explore the file, write down what they notice or what relationships they can find, and then to explain their responses. Angela will go into this in more depth in the next section. So we're now going to go back to the GeoGebra app and create a file of an angle bisector. Now, if you're not following the instructions, I do hope that you'll find in the demonstration some useful hints and tips for using GeoGebra. So across the top of the GeoGebra screen are all the buttons that allow you to create whatever you want. If you click and move across the buttons, the drop-down menus show all the options that are available for you to use. And as you hover over any of those buttons, a small explanation of how to use it appears at the bottom of your screen. We're going to start by plotting 3 points, and we're going to plot them anywhere on the screen. So we click on point, and we'll make our angle nice and big. So I'm creating them with an angle in mind. Okay, so A, B, C. Now, the move button is really important, and you must click on move before clicking anywhere else on screen, because if you don't, then the last function you used will keep popping up on the screen, and it will keep appearing just like this. So there is an undo button over here on the right, and you can undo that. But my advice would be, in between using any of the functions, to click the move button. Okay, and that actually has landed on the origin. So I'm going to delete that point, and I'm going to pop it elsewhere. Okay, so now I want to declutter the screen, and how I'm going to do that is by changing the views. So if we go back to the drop-down menu and go to View, what you'll see is I have selected the Algebra and the Graphics view, and normally when you go into GeoGebra, that's what automatically comes up. Sometimes I do like to use both the Algebra and Graphics, as they do show a connection between the algebra and, in this case, geometry. But for the purpose of today, I'm going to click off my algebra view and just leave the graphics. If you'd like any information on the other views and the other topics that you can use with GeoGebra, contact any member of the team and we would be happy to help. Now, I'm going to concentrate on my angle, so therefore I don't need the grid lines or I don't need the axis. I want students' attention to be on the angle only, and I'm not going to be making any connections to coordinate geometry for this particular task. So I can switch those off by clicking on the right-hand side just under the menu button, and you'll see here an option to hide or show your axis and to hide or change your grid lines. We can also move our graphics view, but we can zoom in and zoom out. So I think that's big enough for you to see. Always remember to click the move button in between. So now that we're left with 3 points on the screen, I want to connect these points to make an angle. If we go back to our buttons, I'm going to look for the button that says line segment. And as you can see, a student will see the difference very quickly between a line and a line segment. When you click on line segment, the instructions come up at the bottom of your screen. So we're going to click on A, B to join A, B with the line segment, and do the same, click on B and then C to create our second line segment. And then we press the arrow. Now to create the angle bisector, I'm going to click on the button for angle bisector. And once again, the instructions come up on the bottom. You click on the 3 points, ensuring that the vertex of your angle is the middle point. So A, B, C. And we have now bisected our angle. Click on the move button. So to make it easier to distinguish between the angle bisector and the arms of the angle, I can click on my line and I can use these buttons up here to change the color, to change what the line looks like. And now it's easier to distinguish between the angle bisector and the arms of the angle. So now to explore the angle bisector. By putting a point on the angle bisector, so point on object, I will put that point anywhere on the angle bisector. I can measure the size of the angle. So if I click on the angle button, again, the instructions are at the bottom, and I need to move anti-clockwise. Click on my 3 points, keeping the vertex in the middle, and click on my 3 points, repeat it for the other side, and click on the move button. So notice how everything is labeled. These are my labels here, and they're very easy. Just once we click on the move button, we can move them around. But also, if I want to change the caption for that label or the color, again, at the top right hand of your screen, you could set the color, change it, but you could also choose to put in the name or the name and the value, or another caption of your choice. So I'm going to leave it at value there. The next, actually, if you right click on any of the points or lines, you will find the same options. So the next step with your students would be to explore the properties of the angle bisector. To do this, we will create perpendicular lines going through my selected point and each arm of the angle. So I find the perpendicular line that goes through a point, and we click from our point to the line, and we repeat on the other side. So from our point to the line. Now, just to make it look a little bit easier on the eye, I'm going to click, oh, there we go. I didn't press the move button. Let's pretend I did that on purpose. So we click the move button to get rid of that extra perpendicular line. Now, if we click on these lines, we can press Control and click on the second one. I'm going to change the color and change how they look, just to make it a little bit easier on the eye. And the second thing I'm going to do is I'm going to pop in the point of intersection. So the reason is because I now want to measure the distance between the arm of the angle and the point. And because this is the perpendicular distance, this is the shortest distance between our point and each arm. So if I find the button for distance or length, we click on that, and then once again, instructions are at the bottom. So we click and we click on D and our other point of intersection. And as you can see, not only are our angles the same measure, but also the distance of this point, the perpendicular distance to each of our arms, is the same. As we can see, these are equidistant, and even as we move the points around, and even as we change the size of the angle, all of those things remain equal to one another. The angles remain equal to one another, and our perpendicular distances remain equal to each other. And this is an example of the dynamic nature of GeoGebra, and how, with the right questioning, students could be encouraged to explore the file and engage actively, creatively, and critically themselves. I mean, you could simply ask them, what do they notice? And if they think that is always true, is it always true that those distances are equal to each other? And as the students explore the file, they could also be encouraged to identify the relationships and to draw their conclusions from this. So could your students recognize that along the angle bisector, we have a set of points that are equidistant from the arms of the angle? Students can explore this file, develop a deeper understanding of the angle bisector in order to tackle unseen problems. And this approach also fosters an inquiring frame of mind. So finally, now that we have created the file, we want to save it and share it. So on the main menu, the 3 horizontal bars, I'm going to go to File, and I'm going to go to Save. Now I'm going to save this as my webinar bisector. And you do have the option to save it as private, in which case you are the only person that gets to see this. Or if you choose to save it as shared, you will be able to share it with your students. So I'm going to save that. And then when we want to share it, you click on File and Share. And you get a link that you can copy and paste to send out to your students. Alternatively, if you go to Open, so if we go into File and Open, you can search for that function. So it's the most recent one, it'll be at the first one, and you click into it, and this will allow you to edit, to view, to rename, etc. So if we go into View It, you will see how your students will view the file. And at the top right-hand corner, once again, are 3 dots. And if you click on those and click on Share, you will see that there's an option to not only share the file, so to copy and paste that link will allow your students to open up that GeoGebra file, but also you can send it straight to Google Classroom or OneNote. And actually, for all the teachers that said they're using Microsoft Teams, if you choose to put it in OneNote, what happens is it does copy a link to the clipboard, but actually, if you go into OneNote and paste the link, your student, now apologies, this is a little bit small, but your students will get the GeoGebra file onto their OneNote and won't have to go into GeoGebra at all. So that's quite handy. I am now going to share a pre-made file with you, and this is an angle bisector that can be used with your students in class. This particular file does contain checkboxes and has a built-in question. So if you had questions about how to create your own checkboxes or built-in questions, do feel free to contact us. This particular file is from the Project Maths website. See here. And it does provide some of the prior knowledge needed before moving into the task that Angela will describe. My final tip before handing over is for searching for help. So there actually is a huge bank of questions and answers on the GeoGebra manual, which is wiki.geogebra, but there's also a GeoGebra forum, and almost any question that you have on using GeoGebra will be answered there. Now, that was a lot of information, and I hope that you could either follow the instructions or that you picked up some useful hint or tip for either getting started with or creating files on GeoGebra or sharing files or even searching for files. As I said, all of those instructions are put together in the document from the Padlet, and they're available for you to download. We'd be very happy to take questions towards the end of the webinar. You can pop them into the Q&A. And I'd like to thank you for your attention and hand you back to Michael.
Thank you for that, Arlene. Some very useful information there for people who are seasoned users of GeoGebra and for new users also. So I'd like to just remind you at this point that all of the resources for tonight's webinar are available on the Padlet. And here it is again in the chat in case anyone missed the link earlier. Also, at the end of this webinar, we will share information about how you can apply for further support from us. And finally, there will also be a question and answers session after Angela talks to you about effective engagement with GeoGebra. So please send your questions in via the chat box at the bottom of your screen, and we'll address as many questions as we can. So now my colleague Angela will take you through GeoGebra, will take you through effective engagement with GeoGebra. Thank you.
Thanks, Michael. So that's great. So you've had a quick overview of how to actually create your own GeoGebra files, and Arlene even shared an example of a file with you there. I suppose just one thing to be aware of: students don't need to have GeoGebra installed or an account in order to be able to open the file and engage with them. But as Arlene mentioned, if they do have the app, then they can save their work. So it's a little bit, they can just get a little bit more out of it that way. But all these links that you create, they're ready to go. So we're going to have a little look at using pre-made files and I suppose the kind of things that we can do with them to try and enhance the student learning experience. So the example we're going to have a look at is actually the in-circle and the in-center. So we can use GeoGebra as a tool to help our students build on the prior knowledge that they would have gotten from junior cycle. We're going to try help them to identify some connections across the syllabus, and we want to focus on the key properties within the constructions, allow them to explore without getting lost in the procedural detail of performing the manual construction. So if we introduce them to the learning through a task, rather than starting with the procedural approach, we might minimize some of the common misconceptions that they encounter and provide students with an opportunity to make some meaningful mathematical connections across the strands before we get to formalizing the procedure. So it's not a replacement for the manual construction. Rather, it's just an opportunity for the students to develop an understanding of the concepts that underpin the construction. And then hopefully to actually discover the steps that are needed to perform the construction for themselves. So that's a powerful inquiry-based approach. And also it can help students in developing strategies to support their problem solving in geometry in general. So in terms of the prior knowledge, I mean, the construction for the in-circle actually has quite a lot, and it draws on a deep understanding of their prior knowledge. So in order to be able to fully engage with this construction, students would need to draw on the learning around the bisector of the angle at junior cycle. They'd also need to draw on a good understanding around circles and tangents in particular. So they'd need to explore the relationship between a circle, its tangent, the point of contact, and its center before they get into the construction. So that can seem like an awful lot of prior knowledge, and they need to be really clear on these concepts. So what we'd like to do is have an approach that allows them to recall that prior knowledge, but do that through an activity. So for example, they could be given a pre-prepared GeoGebra file with just a simple open question that will allow them to investigate and record some conclusions. So the potential of GeoGebra to stimulate inquiry learning, it's really maximized if we complement these assignments with the use of our effective questioning. So what we want our students to identify the important mathematical relationships that are central to the new task. And what we're trying to, I suppose, get to here is an approach that can help promote this inquiry-based approach. So encouraging students to rethink the way they look at diagrams. So we want them to consider diagrams in terms of the relationships that they can identify. And then we're starting to move towards encouraging this positive disposition to solving geometry problems. So the idea is here, they have their question, they have their stimulus, their GeoGebra file, and then for students that are still struggling, we can give additional support. So it could be a video. In the Padlet, I've links to the videos on the constructions. So if this is a senior cycle investigation, whether recalling the knowledge, a link to a support video on the construction of the angle bisector could really help with the task, for example. So we're going to take a look at the file. So very simple question, using the checkboxes, identify and describe the relationships shown. So the kind of things that we're looking at. So again, sorry, this file is in the resource Padlet along with any of the support videos that are mentioned. The kind of things that we're looking at here, so we've a couple of checkboxes. So if we click on the first checkbox, this is revealing the bisector of the angle. And there's some important relationships that we need to highlight. So in particularly, yes, the students hopefully will be able to identify that this is the bisector line, but we want them to go a little bit deeper than that. Maybe identify relationships such as the congruent triangles, perhaps with a proof of those congruencies as an extension to the task. We absolutely could have given our students a worksheet here, could have drawn that diagram, and they absolutely would be able to identify some of those relationships. However, the additional benefit to using GeoGebra here is that they can actually drag the point along and they can see the changes in real time. So they're now moving from describing a single scenario and focusing on one particular example, and they're moving towards an understanding of what's happening across a set of points. So as we drag this point around and the diagram adjusts itself accordingly, the first key property that we want to focus on should become apparent to students. So again, we're thinking in terms of the key learning that they need for the in-circle. So what we're focusing on here is that the bisector line contains a particular set of points which are perpendicular to and equidistant from the arms of the angle. And the reason that that's important is because those particular set of points also contain the circle, and these perpendicular distances are the radius of those circles. So we also want them to recognize something that may not be immediately apparent, but we want them to think in terms of the fact that the arms of these angles are also tangents to the circle. And again, as we move along our line, that's true. There's a circle that we can draw at each set of those points. So we can use our formative techniques to try and figure out exactly what depth of understanding our students have at a particular point. So let them come back to you with all the information. And then based on the kind of things that they say, the conclusions that they're drawing, the relationships that they're identifying, then that can really quickly inform our decision to move forward with the new concept or whether we need to actually take a little bit of time and revisit the prior learning. So the next step then would be to start thinking about the in-circle. So in order to start, we're going to think about the in-center first. We're going to present a problem for students to work on. The example that we're using here, it's just simply, there's 3 villages. You want to place a phone mast equidistant from the connecting roads. So the students have time to go away and think about that individually. So they need to think about the prior knowledge, where they can locate this mast. They can submit their initial conclusions. We can use our formative techniques. What we really want to get out of them, though, is a good mathematical argument to justify their thinking. Now, some of you mentioned that you're using GeoGebra Classroom, and that's fantastic. So students that are comfortable with GeoGebra could go straight to GeoGebra, and like Arlene demonstrated earlier, they can use the tools there to try and work on the problem. But for the rest of them, what we can just do is think about the problem. Maybe that could be a task that they do in advance of the lesson, or it could be the first 10 minutes of a class that they're just working on their own and trying to think about the strategies. And then we can use our pre-made file to bring together the kind of solutions that they're suggesting. So once again, this file and the support videos, they're all in the, there's a support video showing how to create the file I'm going to use, and all of that's in the Padlet, along with the problem. So we'll take a look at the file. So what's on the screen here is just a blank file. And what we have down the bottom, if you look carefully, and sorry for if you're looking on a small screen, it might be difficult to see, but there's these little left and right arrows. And that's a nice function of GeoGebra for demonstrating. If we go into the views that Arlene mentioned earlier, down the bottom, there's this construction protocol. And all that is when I create a GeoGebra file and then enable that protocol, it allows me to play step by step through the construction. So how's that useful? Well, we wanted to propose a strategy for how we're going to locate the mast. So what the students had was they had this triangular situation, and we wanted them to identify a point that's equidistant to the 3 sides of the triangle. So from their prior knowledge of the angle bisectors, it shouldn't have been too difficult for them to identify that, well, if there's points that are equidistant from the edges between 2 of them, well, then let's have a look at those bisector lines, create the bisectors of all 3 sides, and we know that the points are equidistant along each of the lines. So then at some point, they'll cross over, and that particular point should be equidistant from each of the sides. Now, that's what we're hoping that they've gotten to by themselves. And what we want to make sure, though, as well, is that they actually do understand what they've done or how that works. So we might ask them, a few questions around that. So we might ask them to verify that. We might ask them, did they actually need to use all 3 bisectors to find the point? Or whether there's some situations where we might want to create all 3 of the bisectors. We might have asked them to verify. So let's actually go and have a look at that. So we want to verify that this point is actually the same distance from each of the 3 sides. So what we need to do is we need to create our perpendicular distances to each side. So, okay, so these 2 are the same. And in this particular example, yeah, all 3 sides are 2 units away from, and they're all the same. So we're happy enough that we've answered our question correctly, and we verified that the location is correct. So now we need to extend the learning a little bit. So what we're hoping that they notice next is, we leave it open to them, ask them to comment, but what we would like them to notice is that since there's 3 points that are all equidistant from a central location, then we should be able to draw a circle around those 3 points. So we're just working with one context problem and one example. So we're not quite ready to introduce the formal terminology of in-center and in-circle, but what we'd like to do is give our students an opportunity to investigate these properties. So we might ask a question like, would this method work regardless of where the 3 villages are located? If we share a file with an in-circle, then the students can manipulate the file, test out a few different locations, and try to see, does it matter where these villages are? So I wouldn't suggest that they just, choose maybe 3 examples, but if they play around with it for a little while, they can start to notice that it seems that no matter where the villages are, we can always end up with the central location, with the location of the mast being inside the triangle and being equidistant from 3 sides, and with the circle inside the triangle. So previously, they would have done investigations with the circumcircle, and they might have noticed that the location of the circumcenter changes depending on whether the triangle is an acute triangle, obtuse, or right angle. So we'd like them to do a similar investigation here to explore the properties of this new circle. So the dynamic nature of GeoGebra does allow us to identify some of these relationships. So while we can't definitively state without a formal proof, students should be able to recognize that it's likely that the mass will always lie within the triangle. And at this point, we might consider introducing terminology like in-center and in-circle. And now we're going to ask them to explore those relationships within the in-circle. So as they're moving their points around, they're thinking about classifying all of these objects that are labeled in the diagram and what is their relationship to the location of the mast. So the kinds of things that we're looking for them to articulate well and be mathematically precise about what they're saying are things like the fact that AC is a tangent to this circle, that from D to E is the in radius, that H, E, and F, they're the points of tangency, things like that that they can explore for themselves. So we would need to give them sufficient time for these explorations, but by doing that, they might gain a deeper understanding of the key properties of why the construction works. So it is important that they're giving a good mathematical description of how to actually construct that circle. And then when they're clear on the properties, then we can ask them to manually construct it. So they're not getting bogged down with the detail of the construction before they try and figure out the relationships. They're learning first, and then they're going to practice the skill of actually constructing the in-circle. So there's a little bit more that we can get from the problem. So there's some natural connections. So I suppose because GeoGebra allows students to investigate some of the relationships within geometry that are kind of, that can be quite difficult actually to find during the static diagrams, we can easily ask a few questions to extend the learning. So if we refer back to our problem, one additional task might be to suggest that the mast be located this time at a point that's equidistant from the villages. And why would that be a better, or would it be a better location? Why not? And here what we're doing really is we're making the link to the circumcenter. So for example, in the first triangle that I drew, it was a right angle triangle. The circumcenter would lie on the hypotenuse. In terms of the context of the problem, that would lie on the road. But it's not really the problem that's important here. It's that they're exploring the relationship between the in-circle that they've just created and the circumcircle that they've previously worked with. We also want to assess the student understanding. So if our students can provide, for example, a convincing argument that describes the minimum amount of information that they would need in order to construct the in-circle, well, then that's really demonstrating that they have a comprehensive understanding of how the construction works. We could ask another question to make them think about the relationship between the two circles. We could ask, under what circumstances is the circumcenter and the in-center at the same location? And once again, that's a question that would be difficult to manually investigate. But really quickly, they could throw the circumcircle around the triangle and drag it around, compare what's happening there. They can see the changes in real time, and they can pretty quickly come to a proposed solution. And then later on, we might extend the relationships to considering the centroid. So I suppose the important point here is it's about the questioning more so than the tool that we're using. So when we ask these kind of open questions, we're trying to move towards using questions that are at the higher end of Bloom's taxonomy. We're trying to encourage our students to think a little bit more deeply about their mathematics, and we're trying to help them to create a culture of inquiry and investigation. We always have an opportunity with GeoGebra to make the links between synthetic and the coordinate geometry. As Arlene demonstrated earlier, you can use GeoGebra to look at the algebra view, or they can do the manual coordinate geometry calculations and verify what they've just discovered with their synthetic geometry. There is another resource in the GeoGebra file that refers back to the situation I mentioned a minute ago about where your circumcenter and your incenter are in the same location. And there's loads of examples of different GeoGebra files that we can create to explore kind of problems. So this particular example has a file attached to it where it's just mapped out. And again, leave it with the student, ask them a few questions about it, get them thinking about the properties for themselves. And then finally, we know it's not possible to solve every single possible question around the geometry course. So what we're trying to focus on instead is helping our students to develop the skills that they're going to need to tackle unseen problems. We want them to think about the key properties of the mathematical concepts, some of which are being assessed in the final exams. And then when we're using GeoGebra effectively, what we're trying to do is help our students to engage with the key concepts in these problems. So not just focusing on one solution to one particular problem, it's manipulating the files, moving things around, and trying to make connections to some of the big geometry ideas. And we're moving to an idea where students start to see diagrams in terms of the relationships and to explore these key relationships. And then we're helping them to gain a little bit of confidence in tackling those unseen problems. So that's it for me for the moment. There is, as I said, there's a lot in that. And in that resource packet, you will see files. There's quite a good bit of content in there. So please do just feel free to send us a message, ask us any questions, or just throw anything into the Q&A now even, and we'll try and have an answer for you. So thanks very much for that. So I'll pass you back to Michael, and thanks for your attention.
Thank you for all that, Angela. Some very useful information there to digest. Just to remind you, this has been recorded and you can rewatch all of that again. So upcoming workshops, there's teaching maths in a DESH setting. It's an online workshop, and this online workshop will examine some of the factors that affect teaching, learning and assessment in the maths classroom. The dates for that online workshop are Wednesday the 21st, Saturday the 24th, and Thursday the 29th of April. You can book at pdst.ie/online booking and just type in the keyword DESH and you'll find it. We have bite-sized sessions. These consist of 25-minute inputs from a member of the team, and these sessions focus on a specific area of the math syllabus followed by a Q&A. We also offer drop-in clinics, and these comprise of a 20-minute one-to-one meeting with a PDST maths advisor, where the participant can discuss any question around maths, teaching and learning in the current context. And here are a few ways to get in touch with us via projectmaths.ie website, or our newsletter. The link for the newsletter is put in the chat there. Our Twitter handle is @projectmaths_ie, and to email us or to get in touch with anyone on the team, our primary email is postprimarymaths@pdst.ie. The last thing to say is thank you for attending tonight's workshop, and we will stay on for a few more minutes if there are any other questions.